Hello, today I'm going to be showing you my implementation for assignment 1, part 1. To start off, I'm going to run my script that I created to initialize my Docker network, my server, my devices, and also connect them to the network. When we run this script, this will handle most of the initialization for us. Right now we're creating our images, and now we're creating our sensor image. We're not going to launch the containers automatically. We'll do this manually. Let's launch our server container. This is running a simple script to accept packets from all of the devices and handle some basic logic like assigning device IDs to any new device on the network. We can see now that our server is awaiting a packet. Let's monitor the network using Wireshark. Right now, Wireshark isn't showing any UDP packets as there's only the server on the network. So let's start our first sensor device. You can see now that the sensor has sent a number of packets to the server, and the server has successfully received them, acknowledged them, and sent a reply. This packet is just some initialization info. This initialization info is basically just a device saying, "Hello, I exist now. Can you please give me a unique numerical identifier so you can know it's me talking to you in the future?" We can greatly simplify the storage of all the devices on the network and talking to them, and it reduces the need to have to constantly compare IP addresses, instead only dealing with mostly one-digit numbers. Let's take a look at some of the packets that were sent. We'll use Wireshark to do this. First off, we can see that when our sensor launched, that it sent a packet containing the data new:1. This is just a packet sent to the server saying, "Hey, I'm online now and I don't have an ID. Can you give me one?" The 1 in this signifies the type of device, with 1 meaning it is a sensor, 2 means an actuator, and 0 means it's the server itself. The server receives that message knowing that it is a new sensor. It checks how many sensors have already been registered and assigns a new numerical value that hasn't been registered already. We can see this on Wireshark. If we select this UDP packet, we can see that it contains our information new:1. If we check the next packet, we can see that this message was sent from the server containing the information new:0:0. This means that it was sent from the server. This means that the data is 0. And when our sensor receives this data, it will use this as its numerical identifier, with both the server and the sensor storing that information. We then see that the server replies with an acknowledgement that it has received its information, new command from the sensor, and our next packet is from the sensor acknowledging to the server that it has received its numerical identifier. Here we can see that the sensor has sent another packet to the server under the type of UPD or an update. This contains dummy data that mimics what you'd expect from something like a temperature sensor. The server then receives this dummy data and stores it under the corresponding numerical identifier for the sensor that sent it. We can look in Wireshark and we can see these update packets being sent. We can also see the acknowledgements sent from the server in regards to these packets. Let's try and initialize a new sensor device and see what happens. Here we can see our new sensor has sent a new request once again to the server. This time, it has received the unique numerical identifier of 1. This will then go on to send its own update data. And just for good measure, let's launch a third. Now we can see that there is a total of 3 devices registered with the server with the IDs of 0, 1, and 2, each of which will now begin to send its own dummy data, and the server will be easily able to distinguish who is sending. And on both the server and the client, it maintains a queue of unacknowledged packets, and once it receives acknowledgement, it then removes the packet from the queue and will no longer continue to send that packet. Let's take a look at my planned topology for this network. Currently, I have only implemented the sensors and the server, both instantiated in Docker. The actuators are next, but they will not take much more work as their code will be very similar to that of the sensors. My intention for the client is that the server will be hosting a website displaying all the data, and a client in their own web browser will be able to connect to this website, subscribe to the data from sensors, read up-to-date data from each sensor, and also send commands to the actuators and view the status of each actuator. This will allow for a high degree of flexibility and also ease of use that I wouldn't get from a command line application for the client side of things. Lastly, if you would like to see the code for yourself, the GitHub repository is linked in the description. Thank you so much for watching.